following the release of relevant U.S. documents these past few days. Those UFOs you've seen. Those mysterious orbs of light. Those strange flying craft. Those baffling eyewitness accounts. After rigorous investigation, the vast majority have perfectly rational explanations. When military experimental aircraft are tested at high altitudes, they can create eerie optical phenomena. Weather balloons, under specific atmospheric conditions, can appear to move in irregular flight paths. Rocket debris after a launch can be illuminated by sunlight as it falls, appearing as startling shapes on camera. When satellites adjust their orbits, they can create a flickering visual effect. Those alien spaceships that once filled people with dread have all turned out to be classified military projects, or simply extreme cases of natural phenomena. I know, that might sound a bit of a letdown. But please don't be disappointed just yet. Let's broaden our perspective a bit more. Instead of looking at those flickering dots on the horizon, let's look deep into the heart of the galaxy. To truly grasp just how vast this galaxy is, to truly understand how difficult it is for life, especially intelligent life, to emerge. Once you truly understand all of this, you might realize that on this blue planet called Earth, every life form that breathes, thinks, and loves is a precious miracle in the universe. Let's start by talking about some truly massive numbers. 200 billion. Yes, according to astronomers' estimates, the Milky Way contains roughly 100 billion to 400 billion stars. I said stars, not planets. Let's take a conservative middle value of 200 billion. What does that number actually mean? If you were to compare every single star to a grain of sand, the total number of stars in the Milky Way is more than all the sand in all the deserts on Earth combined, including the Sahara, the Arabian Desert, and the Gobi Desert. And the Milky Way is just one of trillions of galaxies in the universe. In the observable universe alone, there are about 200 billion galaxies. Each galaxy contains hundreds of billions of stars. Let's use a more concrete way to wrap our heads around that number. If you started right now and counted one star every single second, without taking a single break, you'd count 86,400 a day and 31.5 million a year. To count the 200 billion stars in the Milky Way, you would need 635 years. And that's just the stars in our own galaxy. If you wanted to count every single star in the entire observable universe, you would need, well, the number is just too huge. There are just way too many zeros. Even more than the stars in the sky. And right here in this sea of stars, we humans are living on the third planet, orbiting an ordinary star. This tiny corner of the galaxy, this blue planet that is, on a cosmic scale, practically insignificant, carries all life as we know it. This is the intersection of our cosmic perspective and human loneliness. The universe is suffocatingly vast, yet the Earth is so small it barely exists. These two facts are true at the same time, and they force us to see our own existence through an entirely new lens. Now, let's zoom in on our solar system. The Sun is a medium-sized star, located on the inner edge of the Orion arm of the Milky Way, about 26,000 light-years from the galactic center. For the Milky Way, our location is equivalent to a single speck of dust on the outskirts of Beijing. Near the center of the galaxy, the stellar density is extremely high, with potentially millions of stars per cubic light-year. In our particular region of space, There are only about 0.4 stars per cubic light year. It's incredibly sparse, almost humbling. Our Sun formed about 4.6 billion years ago. And Earth followed shortly after, coming into existence about 4.5 billion years ago. This timeline means that Earth is younger than the vast majority of stars in the Milky Way. Our Sun is, in relative terms, a young celestial body, while some stars in our galaxy may have been burning for 9 billion years before Earth was even formed. This is a crucial detail. If there really are other intelligent civilizations out there in the galaxy, they could have appeared millions of years before us, or even billions of years earlier. By all logic, they should have had plenty of time to build ships capable of crossing the sea of stars, to colonize the entire galaxy, and to leave their mark in every single corner. Yet we see absolutely nothing. This leads us to the core question we need to discuss. The Fermi paradox. Enrico Fermi, one of the greatest physicists of the 20th century, one of the architects of the atomic bomb, and a founding father of quantum mechanics. During that famous lunch gathering, as he and his colleagues discussed the possibilities of interstellar travel, he suddenly put down his fork and asked a question that seemed simple. Where's everybody? That single sentence changed how humanity views itself. What Fermi meant was, if there truly are so many stars in the universe, then logically, there should be so many planets capable of harboring intelligent life. And, considering the age of the universe, some civilizations should have developed billions of years ahead of us. They should have had more than enough time to colonize the entire galaxy. Their probes should be scattered across every star system, and their signals should be filling every single radio band. Their presence should be like a beacon in the dark, clearly visible. And yet, we see nothing at all. There is no evidence suggesting that in our galaxy, any other civilizations exist. This theory is known as the Fermi paradox. 70 years have passed, and it remains, to this day, one of the most profound and unsettling questions in both science and philosophy. To truly grasp the depth of the Fermi paradox, we need to dive deep into a few key concepts. First, let's talk about the age of the Milky Way. The galaxy formed approximately 13 billion years ago, while Earth is only 4.5 billion years old. This means that, long before Earth was even born, the galaxy already had a history of about 8.5 billion years. Throughout that immense span of time, countless generations of stars were born, burned bright, and died. Supernova explosions forged the very elements needed to build planets and sustain life. If intelligent civilizations really exist in this universe, they should have emerged billions of years ago. Civilizations that are a billion years ahead of us would have technology far beyond our wildest imagination. A civilization a billion years ahead of humanity might have already harnessed the energy of an entire star. Their probes could have already explored every single star. Their presence should be as obvious as gods moving among the stars. But we see nothing. As far as the eye can see, there is only silence. So, where on earth are all the aliens? Scientists have racked their brains, coming up with all sorts of explanations. Each school of thought, from a different perspective, attempts to answer this profound question. The first explanation is called the rare Earth hypothesis. The core idea of this hypothesis is that the conditions on Earth are far more unique than we ever imagined. The emergence of intelligent life requires a series of extremely rare conditions to be met all at once. And these conditions, in most parts of the galaxy, simply cannot be realized. Let's take a look. What kind of conditions does a planet need to be able to harbor intelligent life? First, it needs a star that burns steadily. This might seem like a simple condition, but in reality, the mass of the star has to be just right. If the mass is too large, the star's lifespan will be drastically shortened, burning out before complex life has a chance to evolve on its planets. If the mass is too small, the star will emit too much ultraviolet radiation, destroying fragile molecular structures and preventing life from ever starting. Our sun's mass is just right. It provides enough energy while maintaining a steady burn for billions of years. Second, it needs a rocky planet located in the habitable zone. The habitable zone is that sweet spot, not too far and not too close, where liquid water can exist. Just how narrow is this zone? Take our solar system for example. Mercury is too close, Venus is too hot, Earth is just right, and Mars is too cold. Earth's temperature is perfect for water to exist in liquid form. Just drifting slightly away from this position could cause all the water to either evaporate completely or freeze solid. Third, the planet needs a proper magnetic field. Deep inside Earth is a massive iron core, which generates a powerful magnetic field as the planet rotates. This creates an invisible protective shield that deflects deadly solar winds toward the poles. Without this magnetic protection, our atmosphere would have been stripped away by solar winds long ago, leaving the surface exposed to lethal cosmic rays. Mars once had liquid water and a thick atmosphere, but because it lost its magnetic field, it has become the desolate red planet we see today. Fourth, the planet needs an atmosphere that is just right. If it's too thick, the greenhouse effect spirals out of control, and surface temperatures soar to hundreds of degrees Celsius, much like the hellish surface of Venus. Too thin, and the greenhouse effect isn't strong enough. Global temperatures would plummet. All the water would freeze solid. Even if the atmosphere has the right thickness, oxygen levels must also be just right. Too high, and early life would have burned itself up, triggering a massive extinction. Too low, and complex life wouldn't be able to get enough energy for its metabolism. Fifth, you need a massive moon to stabilize the planet's axis of rotation. The moon's contribution to Earth is far beyond what most people imagine. The gravitational pull of the moon allows Earth's axis of rotation to remain stable, making our seasonal changes mild and predictable. If it weren't for the moon, Earth's axis would swing wildly under the gravitational influence of other planets. From zero tilt to a violent tilt. Seasonal changes would be too extreme to support complex life forms. Sixth, you need countless perfectly timed genetic mutations and natural selection. Evolution itself is a process full of pure chance. Every new trait requires tens or even hundreds of perfectly timed genetic changes. These changes must be preserved through natural selection to evolve from the simplest single-celled organism, step by step into complex multicellular life. A nervous system and a cerebral cortex requires mutations and adaptations too numerous to count. Any deviation at any link could lead to a completely different evolutionary path. All life on Earth shares the same genetic code, which is proof in itself of an incredibly rare event. Seventh, before advanced intelligence can evolve, life must dodge countless mass extinctions, asteroid impacts, supervolcano eruptions, global ice ages, and sudden drops in ocean oxygen levels. Each of these disasters could have wiped out the tree of life that Earth spent hundreds of millions of years building. Dinosaurs ruled the Earth for 160 million years. Yet, in the end, they were all wiped out. by the impact of an asteroid. Mammals lived in the shadows of the dinosaurs for millions of years. If that asteroid hadn't arrived, or had arrived a few million years earlier or later, the dinosaurs might have continued to evolve, and humanity might never have appeared. This isn't just alarmism. It's a statistically near certain coincidence. A species needs to evolve intelligence. Learn to use fire, invent tools, develop language, and build a civilization. Each of these steps is a massive cognitive leap, requiring specific physiological conditions, social environments, and cultural accumulation. The human brain capacity tripled over 2 million years. This process itself is an evolutionary miracle that defies human comprehension. The probability of achieving each step might not seem that low on its own. But when you multiply all those probabilities together, the result becomes despairingly small. Perhaps among the hundreds of billions of planets in the galaxy, only a tiny fraction can simultaneously meet all these conditions. And out of that tiny fraction, an even smaller portion can truly evolve intelligent life. The second explanation is called the Great Filter Theory. This theory suggests that, along the long journey of life from nothing to something, and from simple to complex, there is an extremely difficult hurdle to overcome. Life itself is already incredibly rare, and the emergence of intelligent life is even harder still. Throughout the entire galaxy, there might be only a very few, or perhaps even only one civilization, that has successfully crossed this hurdle. Let's take a closer look at the obstacles that complex life needs to overcome. About 4 billion years ago, the earliest signs of life appeared on Earth. Simple, single-celled organisms drifted in the primordial oceans. These first inhabitants were microbes capable of surviving in extreme environments. Cyanobacteria and archaea. They are still ubiquitous on Earth today. They witnessed the first 3 billion years of our planet. Yet, throughout those 3 billion plus years, life forms remained stuck in a simple, primitive state. There was no significant increase in complexity. The fact that there was a standstill for over 3 billion years is, in itself, a staggering reality. Life is easy to spark, but the emergence of complex life requires a series of extremely specific conditions to align. Research suggests that the key leap from single-celled to multi-celled life requires meeting dozens of criteria. Cells must develop signaling mechanisms between them. They need to form specific organizational structures, and they must evolve cell differentiation and specialized functions. Moreover, these changes must all occur within an environment that is just right. Temperature, pH levels, nutrient concentrations. A shift in any single parameter could completely alter the path of evolution. Perhaps on most planets in the Milky Way, life remains stuck at the microbial stage forever, never producing any complex forms. Hundreds of millions of years may pass, yet only the simplest forms of life whisper in the dark. That sounds heartbreaking, but it might just be the norm for our galaxy. And even if complex life does emerge, the arrival of intelligent life is yet another hurdle. In the history of life on Earth, dinosaurs reigned for hundreds of millions of years, but never evolved intelligence. Their brain capacity relative to their bodies always remained pitifully small. Mammals only rose after the dinosaurs went extinct, and it took tens of millions of years of evolution before a single primate began to use tools and develop language, creating a civilization. It's a process filled with sheer randomness. A disaster, an accident, or a single genetic mutation. Any of these could completely change the course of evolution. If that asteroid had arrived a million years earlier or later, the landscape of life on Earth might look entirely different. If the ancestors of mammals hadn't undergone that one crucial genetic mutation, their brain development might have remained at a primitive level forever. If life evolves intelligence on a planet, it isn't just a matter of time. It's a matter of luck. Infinitesimally small events, over a sufficiently long timescale, can have monumental consequences. Now, let's run a statistical calculation. Based on various estimation models, there are about 400 billion stars in the Milky Way. How many of them are similar to our Sun? Estimates suggest about 15 to 25%. Let's take the median value of 20%. That gives us 80 billion Sun-like stars. Among these stars, how many have planetary systems? The discovery of exoplanets tells us that this ratio is likely quite high. Observations from the Kepler telescope suggest that, on average, each star might host 1.5 to 2 planets. Considering that our current technology still cannot detect every single planet, the actual figure might be even higher. Among these stars with planetary systems, how many have rocky planets located in the habitable zone? Estimates range from about 3 to 20%. Let's take the median value of 10%. That results in 8 billion habitable planets. Out of these habitable worlds, how many actually gave birth to life? An optimistic estimate is 10%. Or perhaps even higher. A pessimistic estimate is 1 in 10,000. Or perhaps even lower. Let's take a middle ground value. Assuming 1%, that's 80 million planets teeming with life. Out of these 80 million life-bearing planets, how many have evolved complex, multicellular organisms? That is a much harder number to estimate. Let's make a conservative guess of only 1 in 10,000. That would be 8,000. Of these 8,000 planets with complex life, how many have produced intelligent beings? Perhaps 1%. That would be 80 planets. Out of these 80 worlds with intelligent life, how many have developed the technology for interstellar communication? Perhaps 1 in 10. That leaves us with 8. Of these 8 civilizations, how many could last long enough to become a true interstellar civilization? Maybe only 1%. That would be less than 1. This is the cold, rational conclusion of statistics. Out of 200 billion stars, perhaps we are the lucky one that made it. All the way from stardust to intelligence. It is not impossible. It is just extremely unlikely. But when the universe is vast enough, and time is long enough, even the most unlikely of events will eventually happen in some corner, at least once. And we are that one time. However, there is a deeper dimension to this numbers game. Even if other intelligent civilizations did exist in the galaxy, why haven't they left any traces behind? This brings us to the third explanation. Civilizations might be self-destructive. Let's look at ourselves. We developed nuclear weapons that can destroy entire cities in just minutes. We burn fossil fuels, changing the climate of our entire planet. Extreme weather events are becoming more and more frequent. We create plastics that are polluting our oceans. Tiny plastic particles have already found in the deepest ocean trenches, on the most remote, snow-capped mountains, and within the human bloodstream. We have created artificial intelligence, something that might one day surpass human intelligence entirely. Yet our control over it remains extremely limited. Are we going to destroy ourselves? Perhaps throughout the long history of our galaxy, countless civilizations have risen and fallen. They might have once looked up at the stars from some distant planet, asking the very same questions. Then, at some stage of their technological development, perhaps through the invention of nuclear weapons, perhaps by hitting a tipping point in climate change, or maybe through some disaster we have yet to even imagine, they met their end. They never got the chance to broadcast their voices into the cosmos. They never managed to build starships. Never had the time to leave their mark upon the galaxy. Before they simply vanished from the universe. All that remained were chemical traces, floating in interstellar space. And these traces require extremely sophisticated instruments to detect. If this theory holds true, then the explanation for the Fermi paradox is this: that intelligent civilizations almost all eventually self-destruct at some stage. And those that didn't destroy themselves are either incredibly rare or hindered by some obstacles we don't yet understand, preventing them from truly expanding into interstellar space. It is a deeply unsettling thought. But it is also a thought that serves as a wake-up call. We may be approaching a crossroads right now. One path leads to sustainable development, the cautious advancement of technology, and the respect and protection of our environment, ultimately allowing us to become a true interstellar civilization. The other path leads to self-destruction, right here on this tiny planet, Earth, bringing a final period to our existence. Which path will humanity choose? It all depends on the choices we make today. Now, let's dive a little deeper. Why is interstellar travel so incredibly difficult? Let's try a simple math problem. The star system closest to us is Proxima Centauri. It's about 4.24 light-years away from Earth. This means that, even if we could travel at the speed of light, which is the universal speed limit for information, it would still take 4 years and 3 months to get there. Einstein's theory of relativity tells us that nothing with mass can ever exceed the speed of light. This one fact completely changes the feasibility of interstellar travel. Let's look at some numbers for comparison. The distance from Earth to the Moon is 384,000 kilometers. It took humans 3 days to reach the Moon. The shortest distance from Earth to Mars is 55 million kilometers. It took human probes about 6 months to make that trip. But the distance from Earth to Proxima Centauri is 100 million times the distance to the Moon. And that's just the nearest star. If an alien civilization wanted to cross the entire galaxy, spanning tens of thousands of light years, the time required would stretch into hundreds of thousands, or even millions of years, for a species with lives as short as ours. These are unimaginable distances. The human lifespan is barely over 100 years, while a journey across interstellar space could take hundreds of generations to complete. But perhaps you're wondering, why can't alien civilizations just build generation ships, letting generation after generation of passengers breed during the journey, to complete a trip lasting 10,000 years? This concept is common in science fiction. But in reality, it faces challenges that are almost impossible to overcome. First, there's the energy problem. To accelerate a spacecraft to a sufficiently high speed, the energy required is staggering. Suppose we wanted to reach Proxima Centauri within 100 years. The ship would need to reach about 4% of the speed of light. For a spacecraft with a mass of 100,000 tons, this would require roughly 10 to the power of 23 joules of energy. What kind of scale is that? It's equivalent to billions of times the total annual electricity production of the entire planet. Even with the most optimistic nuclear fusion propulsion plans, you would still need to burn through the mass equivalent of dozens of asteroids in fuel, and maintaining a system on the ship that can sustain a population for thousands of years. A system that perfectly cycles air, water, and food. A system capable of providing sufficient psychological support within a closed environment, is unimaginably complex. If even a single link breaks down, an outbreak of disease, a collapse of the food chain, a mental breakdown or social unrest, it could destroy the entire journey in an instant. Then there's the issue of radiation. Outer space is filled with lethal, high-energy rays. Gamma-ray bursts, cosmic rays, solar winds. They come from every direction, non-stop, constantly. On the surface of the Earth, we are protected by our magnetic field and atmosphere. But aboard an interstellar ship, passengers would be exposed to constant radiation bombardment. This kind of radiation would cause cancer rates to skyrocket, lead to the accumulation of genetic damage, and cause cognitive decline. History's nuclear radiation accidents have already shown us the terrifying consequences of radiation, yet the radiation levels in interstellar travel would be tens of thousands of times higher than the worst nuclear disasters on Earth. To build a shield thick enough to block that kind of radiation would drastically increase the ship's mass, making it even harder to accelerate, creating a vicious cycle that's nearly impossible to break. Third is the problem of technical maintenance. A ship flying for 10,000 years needs to keep every single system running without any external supplies. The aging of any single component, the failure of any piece of technology, any unexpected malfunction could lead to total disaster. To build a complete industrial system inside a spaceship to produce parts and fuel is like trying to build an entire city inside a bottle. You need factories to make the tools. You need mines to extract the raw materials. You need energy to power it all. And you need hospitals to treat the sick and injured. Every single subsystem has to run perfectly. Otherwise, the whole thing falls apart. Fourth is the risk of the destination itself. Even if the ship successfully reaches the target star system, is it actually suitable for survival? What are the specific conditions on the planet? Is the landing safe? Is the place already occupied by other life forms? Or worse, does it harbor intelligent life? These questions can't be answered for sure before leaving. And once you find out the target planet isn't habitable, the entire journey becomes completely meaningless. Yet the people on that ship will have already been drifting through the stars for generations. Therefore, crossing interstellar space for any civilization, bound by the known laws of physics, is an incredibly difficult challenge. We might never be able to truly pull it off. But let's dig a little deeper. Even if an alien civilization could solve all these technical hurdles, there are even deeper problems waiting for them. Time. Let's imagine a civilization 1,000 years ahead of humanity. Their technology is advanced enough to build generation ships, to carry enough supplies, to shield against interstellar radiation, and to keep society running throughout the long voyage. They decide to send colonists to the nearest star system in the galaxy. The ship departs, but even traveling at near light speed, it still takes years to reach the destination. For the colonists on the ship, it's just a few years. But for the people back home, they have to wait for decades. And it could even take hundreds of years to receive word that the ship arrived safely. And if they really wanted to colonize the entire galaxy, well, considering the scale of the galaxy, from one end to the other, the distance is about 100,000 light years. Even traveling at the speed of light, it would take 100,000 years to get from one side to the other. And during that entire process, every time they reached a new star system, the colonists would need time to build a new home, raise the next generation, and accumulate resources before they could even launch the next ship. This means that, for a civilization looking to colonize the whole galaxy, The time required isn't just a few hundred years, but hundreds of thousands or even millions of years. This time span is already approaching the natural evolutionary cycle of certain species. And that's also assuming they could find enough habitable planets. Assuming their technology could be passed down through generations. And assuming their social structure could remain stable throughout such a long interstellar colonization process. In reality, every single one of those assumptions is filled with uncertainty. Planets in the galaxy that are truly suitable for complex life to survive on might be far fewer than most people estimate. Technology could be lost while being passed down. Civilizations could collapse in the face of setbacks. And societies might, over the long march of time, lose the drive to move forward. This is why, even if many civilizations have existed in the galaxy before, very few of them were ever able to truly become an interstellar civilization. Even if they occasionally sent out ships to explore neighboring star systems, it would be very difficult to have an observable impact on the scale of the entire galaxy. And we just happen to be the ones who might be the lucky winners who actually made it. Now, let's return to that initial question. Are the UFOs you see real? The answer is, in most cases, yes, they are real. They just aren't alien spacecraft. Those bright spots streaking across the night sky could be astronauts on the International Space Station, orbiting 400 kilometers above us, circling the Earth, experiencing a sunrise and sunset every 90 minutes. When the International Space Station's solar panels reflect sunlight, to those of us on the ground, it looks just like a bright point of light, moving rapidly across the sky, sometimes even flickering on and off. Those shooting stars with long, glowing tails might just be a tiny bit of space dust, burning up from friction as it enters the atmosphere, leaving behind a flash of brilliance. These meteors happen several times every hour. But in our brightly lit cities, hardly anyone notices them. Those spots of light that dim and brighten could be a distant man-made object, a satellite launched by humans. At certain times, when the satellite's metal casing reflects sunlight down to the ground, it creates a brief, bright flare before quickly fading away. This phenomenon is called a satellite flare. At specific locations and times, you can even see it with the naked eye. Those strange shaped patches of light might just be optical artifacts caused by a camera lens facing a strong light source. When you point a camera at the moon or a bright star to record, you can sometimes get halos, starbursts, or lens flares. To an untrained eye, these might easily be mistaken for a UFO. Even those classic images of saucer-shaped unidentified flying objects, many of them are just kites, drones, or balloons. Under specific lighting conditions, it takes on a unique shape. So the next time you see something strange in the sky, don't be so quick to assume it's an alien. Take it as an opportunity to learn more about atmospheric optical phenomena, satellites, and astronomical wonders. That in itself is a truly fascinating thing. But more importantly, it allows us to see this world through a new pair of eyes. We live in a universe that is already magical enough on its own. We don't need aliens to add mystery to it. There are 200 billion stars in the Milky Way, each one forged from elements created by a supernova explosion billions of years ago. There are 8 planets in the solar system, each with its own unique story. There are over 10 million forms of life on Earth, each one the product of over 3 billion years of evolution. When you look up at the starry sky next time, try to feel that vastness. Try to imagine that every glimmer of starlight might be a flame that has been burning for billions of years. Feel the profound depth of time. And understand that you, right now, in some corner of the universe, exist in a way that is brief and precious. This brings us to the last topic of today. If there are no aliens in the universe, what does that mean? We've discussed the grandeur of the galaxy, the rarity of intelligent life, the difficulties of interstellar travel, the shadow of the Great Filter, and the risks of self-destruction. All these discussions, in the end, should not lead to despair, but to appreciation. Just think, right now you are lying in the most precious corner of this universe. Your body is made up of about 37 trillion cells. And every single one contains your complete genetic information. It guides every single one of your biological processes. There are iron atoms flowing through your blood. Iron forged billions of years ago, deep within the heart of a dying star. With every breath you take, you are exchanging oxygen atoms that are shared by every living thing on Earth. Your very existence is, quite literally, a miracle spanning 10 billion years. In this vast universe, perhaps there truly are no other voices out there. Perhaps we are shouting into the darkness, destined to never receive a reply. But precisely because of that, every being that can love, that can cry, that can dream, and that can feel fear, becomes all the more precious. We needn't feel saddened by this. Sometimes, loneliness is a form of nobility. When we realize how small yet how precious we are, we can actually face all the ups and downs of life with greater composure. Instead of seeking validation in the vast crowd, it is better to cherish every genuine connection right by our side. Instead of waiting for some unreachable, alien civilization to come and save us, why not use our own two hands to create a life worth remembering? Somewhere in a corner of this universe, there is a small group of lives looking up at the stars, striving to understand the mysteries of the cosmos. They will laugh, they will shed tears. They will give everything for a distant dream. And they will find happiness in the smile of a loved one. Isn't such an existence itself the most beautiful miracle of all? Perhaps in some remote corner of the Milky Way, another civilization truly did rise once. They, too, looked up at the stars. They, too, asked the same questions. And they, too, dreamed of traveling among the stars. Their light eventually faded into eternal silence, leaving behind nothing but chemical traces drifting through interstellar space, waiting to be discovered by some future traveler. And yet, here we are, telling this very story. We use our own minds to unravel the mysteries of the universe. We use our own language to share how we feel with one another. We use our own hands to craft the possibilities of the future. And that in itself is a victory. A victory that no other civilization could ever replicate. If we are truly all alone, then our existence is the most extraordinary event in the entire universe. But if we are not alone, then our meeting would be a miracle even more extraordinary still. Either way, we are worthy of gratitude simply for existing. You don't need aliens to arrive, just to prove that humanity is not alone. You have family and friends right by your side. Loved ones, colleagues, and even strangers. Every single one of them is a fellow soul sharing this universe with you. Every conversation you have, every hug you share, and every laugh you enjoy together, are all events worth recording in the galaxy. If there are no other voices in the universe, then we shall be our own voice. In this universe that belongs to us alone, we can forge a meaning all our own. If we are the only civilization in the galaxy, then let us use our own hands To build a civilization worth remembering. Every act of kindness. Every tool we invent. Every song we compose. Every word we write down. All of it is part of human civilization. And all of it is the mark we leave upon this universe. Good night, and may you meet those distant starlight dreams tonight.